Okay, let's have a look at question 5.1.1, which we just did previously. Now, let's look at an alternate method. So, previously we used a representative rectangle with a breadth of delta y. Now, what happens if you use this type of rectangle? So if you use a rectangle with a breadth of delta x, okay. So let's have a look at the area. So we know that this is the area. So now, if we use a representative rectangle of delta x, then let's sketch the representative rectangle inside. So here's one here. So if I draw my representative rectangle here, here's my delta x. If I draw my representative rectangle here, what do you notice? You notice now that there are two different areas. Okay, there's an area from x is equal to 0 to x is equal to 1, which we've already calculated. If you refer to the previous example, the x-intercept of the natural log graph is 1. So now, from 0 to 1, if you look at this line here, there is an area. Okay, so here is your area. Then from x is equal to 1 to this point, which we need to find, we have a different area. How do we know that? We check the rectangle, check what's touching the top end, what's touching the bottom end here. The top end is being touched by y1, which let me call this y1, let's call this graph y2, and let's call this graph y3. So this is y1, y2, y3. So if we analyze this, we check that this point and this point here. So this is y1 and this point here is y2. Okay, now let's have a look at this point here. What's touching the top end here is y3, and what's touching the bottom is the x-axis, and on the x-axis y is equal to 0. So let's call this part area 1 and area 2. Okay, so we need to know from 0 to 1 and then from 1 to this point here. Right, so now from 0 to 1, let's have a look at that area. From 0 to 1. From 0 to 1, this is the area that you have. If you look at it, there's my 0, there's my 1. Okay, and I know here that if I look at this line here, it's x is equal to 1 here, and y is equal to 2. So that is 1, 0. This is 1, 2, and this is 0, 0. This is a right angle triangle. Although we're not going to be using the right angle triangle formula, we will use integration. But the fact is that when you draw a straight line perpendicular to the x-axis, you have a right angle triangle. Right, and if I want to work out the area here, so this is area is going to equal to half base times height, so that's going to be half. The base is from 0 to 1, which is 1, and the height, so therefore 2 divided by 2, that is 1 units squared for area number 1. Okay, but now let's use integration and work out the area. So let's go for area number 1. So 5.1.2. Right, so 5.1.2 was calculating the area. Right, so we have two areas, area 1 and area 2. So area 1, so what do we have here? We're going to go delta A, which is area, is equal to length times breadth. So let's go to our diagram. The length is from here to here, so it's y3 minus 0. So therefore, that's going to be y3 minus 0. That is the length, and the breadth is delta x. So your breadth is delta x here. So then your total area 1, you're going to integrate, that's b and a, y3 delta x. So what is your b and a there? Starting at 0, ending at 1. So there's my 0, 1. What is y3? y3 is 2x. So get y3 in terms of x, that is 2x. So therefore this is going to be 2x squared over 2, and then we're substituting 1 and 0. 2 and 2 cancel, so you just end up with x squared, that's 1 and 0. So therefore, I will substitute 1 there, so that's 1 squared minus 0 squared, and 1 squared is 1. So this is using calculus, using integration to work out the area. Here, we noticed that there was a right angle triangle, so we can always check our answer by working out half base times height. Alright, so this is area 1. Now what about area 2? Area 2 is from this point to this point here. There's the area 2 here. So let's deal with area 2. So area 2, we're going to go delta A is equal to, area is equal to length times breadth. So therefore, what is the length for area 2? So you check the top and the bottom. The top is y1, the bottom is y2. So the length is going to be y1 minus y2 times the breadth there, which is delta x. Now, total area 2, we're going to integrate, so that's b and a, y1 minus y2 dx. What is your b and a now? Okay, so let's work this one out. What we need to do, what we know at the moment is we know this point here is a 1, but we do not know what b is at the moment, because b is the x value at this point here. What we know is that y is always equal to 2 at that point. So check which two graphs are intersecting at this point here. It's y1. There's y1 here, and this graph here is y2. So what do? We make y1 equal to y2, work out the points of intersection. So what is y1? y1 is 2, and y2 is 2 ln x. So I need to solve for x. 2 divided by 2 is equal to ln x. So ln x is equal to 1. Remember, the base of natural log is e. So therefore, converting from log form to exponential form, x is equal to e to the power 1. So therefore, the point of intersection here is when y is equal to 2, x is equal to e. So there's my e. Right, so we got that point. What is y1 in terms of x? y1, where is y1? Where did I label? Now y1 is 2 minus y2 is 2 ln x. Okay, so now we can integrate this. So this one is integration by parts. There are two separate problems here. There are two separate terms. You integrate 2, you're going to get 2x. Okay. So minus 2 times, we need to integrate ln x now. So when you integrate ln x, if you refer to yesterday's problem, remember this is going to be integration by parts. So this will be f of x, g of x minus the integral of g of x times f prime x dx. So let's see what happens here. We got 2x minus 2 f of x, g of x minus the integral of g of x f prime x dx. You know when you integrate ln x, it's going to be ln x times 1. That's what it is. So this is going to be f and this is going to be g prime. Okay, which we have done previously, we shouldn't have any problem working this one out. So, what is f? F is ln x. G is not 1, g prime is 1. So g will be the integral of 1, which is going to be x. So there's my x here. Whatever I write down here, I copy down there, there's my x. F prime x means differentiate ln x, which is 1 over x. So now we got 2x minus 2. And then I have here, that's going to be x ln x minus the integral of 1. So therefore I got 2x minus 2. That's going to be x ln x, integrate 1, that will be x. So therefore I got 2x minus 2x ln x. And then I got plus 2x. Because negative times negative there is positive. So I'm getting 4x minus 2x ln x. Finally, everything has been sorted out. We need to substitute e and 1. Let's see what we get. Alright, so we got 4x minus 2x times ln of x, substituting e. To get e on the calculator, you press shift ln and put power 1. So we're getting 5.436563657, and then if we substitute 1, we get 4. So therefore, the area is going to be basically 5 minus 4. So it's going to be 1, comma 4, 3, 6, 5, 6, 3, 6, 5, 7 units squared. So that is area 2. So total area is going to equal to area 1 plus area 2. Area 1 plus area 2. So you're adding up 1,436 and you're adding 1. So that's going to be 2,436563657 units squared. So that is the total area using delta x. Right, so that was the first part. Now, the second part is to work out the centroid. So, let's do that. Right, our next question here was calculate the calculate the area moment about the y-axis as well as the x coordinate of the centroid of the area described. Okay, so basically we want to find the x coordinate of the centroid. So you have said the centroid, we want x, so therefore x is equal to we are choosing a representative rectangle with a breadth of delta x. So therefore, our centroid will be labeled in this way. So the coordinates here will be x, and then it's an x value, and then to get the midpoint here, this is what, y3 plus 0 over 2. Okay, so that's y3 plus 0 divided by 2. What about this one? Here, you have an x value here, and then the bottom, what is the bottom graph here? Y2, and the top graph is y1. So this is going to be y1 plus y2 all divided by 2. So that's how you label it, right, compared to the previous example. So again, we are dealing with area 1 and area 2. So let's start with area 1. So for area 1, we got delta my. Okay, what we want to do is we need to work out the moments about the y-axis for area 1. We need to work out the moment about the y-axis for area 2. Then we get our total moment, and then we can divide. Because we got 2 moments, we need to add them up. So the moment about the y-axis is area, which is delta A, times distance from the y-axis. Okay, so we're talking about area number 1 from the y-axis is an x value. Okay, so if you are measuring from the y-axis, you are measuring an x value, so that will be times x. If you're measuring from the x-axis going up, you are measuring a y value. Right, so remember that. So what is area? Delta A area is length times breadth. So what is the length of here? We're talking about this one, area 1, the length. Remember what's touching the top is y3. So that's going to be y3 minus 0, which is just y3 times delta x times x. So that's your area times the distance from the y-axis. So then my, we're going to integrate, that's b and a. So that's going to be y3 times x dx. Alright, so now what is your b and a for area number 1? There's here 1 and 0. So there's your 1, there's your 0. What is y3? y3 is the equation of that straight line, which is 2x multiplied by x simplified. So that's going to be just x squared. So this is going to be 2x to the power 3 over 3. And then we're substituting 1 and 0. We don't need to use a calculator here. You're going to substitute 1, you're going to get 1 over 3. You substitute 0, you get 0. So 1 over 3 times 2 is 2 over 3 units to the power 3. Because, remember, first moment of area is units to the power 3 because area is squared and x is a unit. Unit squared times unit will be units to the power 3. So that is area number 1. Let's deal with area 2. So for area 2, delta my is going to equal to area times distance from the y-axis. So this is that we're dealing with this one. Distance from the y-axis is x. So that's your x there. So what is the area for area 2? Area 2 is, remember, length times breadth. That's a y1, and this is y2. Just like how we worked out previously. So it's going to be y1 minus y2 times delta x times x. So therefore, my, we're going to integrate this b and a, y1 minus y2 times x, and there's your dx. We are integrating with respect to x. So this is going to be your b and a. We've already worked that out previously. Remember, there's the point here, which is e and 2, and this point here is 1 and 0. So we are interested in the x values. Remember, the point of intersection there was e, and that is 1. What is y1? So y1 is 2 minus what is y2? y2 is 2 ln x multiplied by x. Right, so now let's integrate this. This is integration by parts. Again, okay, so integration by parts, how do we know that? Because x is being multiplied by x. If you want to separate this into two problems, you can. Okay, you can if you want to. But what I'm going to do now is I'm going to treat this whole thing here as my f of x, and this one will be g prime x, because from your priority list, number 1 is inverse, number 2 is log, so then number 3 is your exponent x. So let's see. Right, so what I'm going to do is I'm going to treat this whole thing here as f, and this will be g prime. So the formula is going to be f of x times g of x minus the integral of g of x times f prime x dx. So what am I going to do here? I'm treating this whole thing here as my f of x, which is 2 minus 2 ln x. Then this is going to be g prime. So when I want g, I need to integrate x, so that will be x squared over 2. Remember, whatever I write down here, I copy it here, which is x squared over 2. And then f prime. Now remember, this is f. So f prime means differentiating. So the derivative of 2 is 0. The derivative of 2 ln x is 2 times 1 over x, which is going to be 2 over x. Right, that's all. Simple. Derivative of 2 is 0. Derivative of this. Derivative of ln x is 1 over x times 2 is 2 over x. And there's your dx. So now I have 2 minus 2 ln x times x squared over 2. And now we can simplify this. This is 0, that's out. So what's going to happen here is a negative and negative is a positive. 2 and 2 cancel. And I just have x squared divided by x, which is x. So now that is my 2 minus 2 ln x times x squared over 2 plus integrate x, that's going to be x squared over 2. And now we are ready to substitute these values, which is e and then 1. Let's work it out. Let's see what we get. So we got 2 minus 2 ln x times, let me redo, 2 minus 2 ln of x. So that will be times x squared over 2, so that is x squared divided by 2 plus x squared over 2 again. So what are we substituting? E. So when we substitute E, we are getting 3,694,528,049 minus, if you substitute 1, you are getting 3 over 2. So let's do the subtraction. And then I end up with 2, 1, 9, 4, 5, 2, 8, 0, 4, 9 units to the power 3. So this is the moment for area 2. So this is area 2 moment. This one was area 1 moment. So we need the total. So the total moment is equal to, we need to add up 2 over 3 plus 2,194528049 and 8 plus our 2 over 3, and we get 2,861,194,716 units to the power 3. So therefore x is going to equal to my over a. And what was my total my? Total my, which we just worked out now, is equal to 2,861,194,716 divided by the total area. What was our total area? It was 2,436,563. 2,436,563,657. Right, so that is units to the power 3. This is units squared. And let's see what we get now. So we take that, we're going to divide it by 2.436563657, and we get 1,174,274,56, which is equal to 1,174 units. And that is the x-coordinate of the centroid using a representative element with a breadth of delta x. Right, it's your choice in the exam.